to determine the rate of reaction for each of these lines, right? Then for temperature you have 5. You need to determine the slope of each line. The slope of each line tells you the rate of reaction. And the way you determine the slope is you go back to, I don't know, arithmetic, algebra. The equation for determining the slope of a line is this one, y2 minus y1 over x2 minus x1. Right? So let's take my asterisk example. So I labeled this line here. I labeled this line here with an asterisk. We're going to determine the slope of just this line. You got to determine the slope for each line. But I'm just going to do an example of this line right here. Okay. So for this line, right? Remember your x is your time, the x-axis. Your absorbance is your y-axis. So you just write down your time, 0, 20, 40, 60, 100, 120. And then your absorbance for just that line. So I made up some numbers here, right? And then you just take two values, anywhere between these, preferably a low and a high, and then you plug it in. So y2 would be 0.04 minus y1, which is 0.01, yeah. Hard to read in here.
There you go.
There we go. I like that.
Y1, Y2.
Yeah.
I like shapes.
Right? So y2 minus y1 over x2 minus x1. So 0.4 minus 0.1 over 80 minus 20 gives me 0.3 over 60, which gives me 0.005 absorbance per second. The slope is the change in absorbance over change in time, so 0.005 absorbance per second. I hate graphing things with lots of zeros, so I just converted the seconds to minutes. So I just multiplied 0.005 by 60 to give me 0.3 absorbance per minute. So for that one line, it's 0.03, so I don't know, it's right here. So that's I don't know, that was my temperature 23. Right, so my temperature 23 was right there. Right, let's say I do this slope for temperature 4, maybe it was here. My slope for temperature 32 was, I don't know, here. Or 48, oops. Maybe it was here. And 99, maybe it was here. So now if you connect the dots, you can now see an optimum temperature. So the optimum temperature now is 32 in this example. Right? So you're going to do the same thing for the temperature and pH. So remember, each dot is the slope of each line. Right? And that's how you determine not only the optimum temperature or the optimum pH, but also the rate of reaction. Right? So at 23 degrees, you get a rate of 0.3 absorbance per minute. Right? At 32, you get a rate of, I don't know, 0.4 absorbance per minute. So the rate of reaction is greater at 32. Alright? Does that make sense, how you do the derivative graph? That's how you do the synthesis part. So you have to do the slope for each line. For temperature, each line for pH, and then you can generate your derivative graph to find the optimum. Got it. If you don't want to work with lots of zeros, 0.005 per seconds, you can just multiply it by 60 to get per minute, and it's a little bit better.
Yeah.
Okay?
Well, that's straightforward.
Questions on